Okay, let's take a minute and finish going over the notes for this material. All right, so number one, I did not go over this in the last video and I want to make sure you understand it. It says a graph of a polynomial function has at most n minus 1 turning points. And you're like, well, what exactly does that mean? So remember that n is your degree. So if you have something that is degree 3, then that means there's going to be at most 2 turning points. So if you think about this, okay, degree 3, let's just draw a general graph of what it could look like. Okay, so there's a turning point right here because it turns and goes down. Here's a turning point right here because it was going down and now it's turning and going up. So it has 2 turning points here and here. It does not have to have 2, it could only have 1, that's okay, but it will have at most n minus 1 turning points, okay? So let's just say we have something with a degree of 2, it will have at most 1 turning point. So a degree of 2 is going to be a parabola, and if you notice here, here's the turning point. We went down, and then we're turning and going back up, okay? So that would only be 1 turning point in this case, okay? Now, it says if a function has n distinct real roots. Okay, so what that means is all of the x-intercepts are different. Okay, it means there's no double roots. Okay, it means there's no triple roots. It means there's no roots to the fourth, etc. Then it has exactly n minus 1 turning point. So what I mean here is, let's say you have x minus 3 times x minus 2 times x minus 1. Your roots are going to be x equals 3, x equals 2, and x equals 1. Those are 3 distinct roots, okay? Now, let's say we change that so that it looks like x minus 3 squared times x minus 2 times x minus 1. Now here, this x minus 3, this has a root of 3, but it has a multiplicity of 2 because x minus 3 squared is really x minus 3 times x minus 3. So that 3 is repeated, and that's going to be a what we call a bounce point, okay? This one is going to have 2, x equals 2, and this will be x equals 1. So just be careful there. This one does not have 4 distinct roots. This would be a degree of 4 because we'd have 1, 2, 3, 4, x to the 4th if I multiplied it out, but this one is repeated or is double. This is a degree of 3, okay, because if I multiply this out, I'd have x a third, all right, and there's exactly 3 different roots, okay, so n different or distinct real roots. All right, so what I would like you to do next is I would like you to take a minute and try this question below. Okay, you're going to identify the characteristics of the function. Remember to use correct interval notation. Okay, and remember that up here, your interval notation is going to be the information that I went over up here. So I want you to take a minute. I want you to pause this video. I want you to try this with your classmate sitting next to you. And then I want you to go ahead and start the video again in order to check your answers. Okay, so hopefully you had a minute to check your answers, and what I'm going to do is I'm just going to kind of go over a few things before I actually go over the answers here. So let's just start with our graph going left to right. Notice as I go from here to here, what is my graph doing? If I'm a little person starting at the end, I'm walking up, 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 up the hill. I'm going to put a plus sign here to show that that graph is actually increasing. So you're walking up the hill. Once I start to this point, negative 3, 3, I'm going down, 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 down. So I'm going to put a negative sign here to show that this portion of the graph is decreasing. Okay, notice up here I'm going up, 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 up. I'm going to put a positive sign here to show that my graph is increasing. And then here, this is my turning point. I'm going down, 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 and my graph is going to start decreasing. So if we kind of want to do that with different colors, we could say this is where we're increasing. There's my turning point. I'm turning and changing down. Okay, there's a turning point. I'm turning and I'm going up. There's my turning point. I'm turning and I am going down. Okay, so now let's answer the first 2 questions here where we're increasing and decreasing. So where did I start when I started increasing here? Well, this is going down towards negative infinity. So I actually started increasing at negative infinity all the way up until -3. And remember, with your increasing and decreasing, you use your x values only, okay? So that's for your increasing and your decreasing, or your x values only, all right? Now, where else am I increasing? So I started here at +4, and I increased until I hit x is equal to 8. All right, make sure you put a union between them, and notice here that they're in parentheses because these are turning points. So we're not including those points. It's like a stop sign. You're stopped there. You're not increasing or decreasing. All right, so decreasing. All right, so here I started at -3 and I'm going down until x equals 4. Okay, so at -3 to 4. And then here I started at 8. Okay, and then I started decreasing at 8 all the way until infinity. Now, this is not negative infinity, it's not the y values. What are the x values? So as the x values get bigger, it's going down, 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 down. So from x equals 8 until infinity, until x is infinity, my graph is going to decrease, okay? Now, your zeros are your function. Remember, those are the same thing as your x-intercepts. All right, so in this case, we have 1, 2, 3, 4 of them. All right, so we have 4 x-intercepts, and that can be x equals -6, okay, at x equals 0, at x equals 5, and x equals 10. Okay, now points of inflection. Remember, your points of inflection are going to be where we change from concave up to concave down. Okay, so that can be a little bit tricky with your concavity. All right, so let's just take a minute. Okay, so let's just take a minute and decide which part of our graph is concave up and which part of our graph is going to be concave down. All right, so and then we'll decide our points of inflection. So remember, your points of inflection are going to be where the graph changes from concave up to concave down. All right, now remember that concavity is sort of like thinking of looking at like the top of a hill and a bottom of a hill. So notice how this portion of the graph, okay, right here, this is kind of like going up a hill. All right, so that is going to be, that is where we're concave down. Okay, so think of like you're starting at the top of the hill and you can go down either side. That's concave down. Now, where else do you see that we're concave down? So if you notice right here, this portion of the graph right here, okay, this is also concave down. Okay, so concave down, once again, you're standing at the top of a hill. I could go down either side. Now, concave up is a little bit different. So concave up, I think of like it as drinking out of a cup. Okay, so here's the cup that I can drink out of, and this is concave up. Okay, all right, so now your points of inflection are going to be where we change from concave down to concave up. So notice right here, this point right here is where I went from concave down to concave up. Now, I know that for right now, you're just going to kind of estimate these. We have nice points sort of written on here, but there might be a point where you might have to guess a little bit. That's totally fine, okay? All right, so notice this is concave down. At this point right here, this is a point of inflection. I'm changing from concave up to concave down, all right? So that point of inflection right there is 6, 1. Now, notice how this says point of inflection. So that means you're going to include your x and your y. So point of inflection means you need to include that point. All right, and then I'm going to put some curly braces around these to include that there are both of them. All right, now let's take a look at the next question where it's asking me, where is my graph concave up and concave down? This is going to be where you are going to use your x values, okay? So you're using your x values only here. So concave up is starting at x equals 0, okay, all the way here until x equals 6. So it's concave up from 0 to 6. Now, where is it concave down? What is this x value? Well, this is x is negative infinity because this This is going to the left forever and ever and ever. So this is concave down starting at negative infinity for x, okay, and going all the way until x is equal to 0. Okay, notice once again that we have parentheses around these, okay, and the reason they're parentheses because that's a turning point, okay, so we're changing, potentially changing direction, and it's changing direction from concave up to concave down. It's not a turning point in the increasing and decreasing, but it's sort of turning from concave up to concave down. All right, and then we had another part that's green where it's concave down. It started at x equals 6, okay, and then x was going towards forever to the right, so it's from 6 to infinity, okay? And then you want to make sure you put that union symbol there, and you can also put braces there if you wanted to. All right, now let's take a look at the next two, relative min and relative max. Those are going to be your y values only, and the reason they're y values is if you think about it, we're seeing how high and how low the graph goes, okay? Now, absolute min and absolute max is how high it goes anywhere, and absolute min is the lowest it can go. Relative means it's sort of like the top of a hill and at the bottom of a hill. So we do have a relative max right here. If you notice this first one here, this is like the top of a hill, so that is going to be 3. Okay, we have another relative max, okay, which is going to be at the top of this hill right here, which is 5. All right, now notice if I write 3 comma 5, if I put parentheses around that, I'm going to think that that's an ordered pair or an interval. It's not, it's just 3 points. So that's why I have to use my curly braces here, because it's not an interval and it's not a set of ordered pairs. Okay, so relative min is the lowest of all the points around it. Think of it as like the bottom of a hill. So -4 right here, this is your relative min because it's at the bottom of the hill. And remember, we're going to use our y values only. Okay, and once again, let's put braces around this, okay, in order to show that this is one y value. All right, now the absolute max and the absolute min. The absolute max is the highest the graph will ever go. If we look right here, this graph is never going to go higher than this point right here. And what is that y value? That y value is 5. It's never ever going to go higher than 5. Okay, let's make sure we put braces around that. Now the absolute min is the lowest it's going to go. How low will this graph go? Well, it's going to keep going down forever and ever and ever and ever. So there is actually no absolute min. Okay, we cannot say, so you cannot say negative infinity. So the min is negative infinity. Well, then we don't know what negative infinity is. It doesn't exist, all right? It's a direction, not a number that it's going towards, okay? So just be careful with that. If you have questions on this, please feel free to let me know.